Hi, welcome to Linear Functions and Models. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This particular lecture is for my students in Math 1320 at UTEP. Linear Functions and Models, I broke this into two parts. First, part one is just the skills, which is look at linear functions. Part two of the next video, we're going to take a look at word problems. So start with a definition. A linear function is one that can be written in the form f of x equals mx plus b or y equals mx plus b, where m and b are fixed numbers and x is our variable. Linear functions, the word line is contained in there. They have graphs that are lines. The role of m, this number m is called the slope. If y equals mx plus b, then y changed by m units for every 1 unit change in x. And if you watch the previous video, as the price increased, the demand went down by 3 people that didn't want my skateboards anymore. So m is as the x goes up by 1, the y changes by m. And this leads us to a slope formula. A slope formula allows us to take 2 points, x1, y1, and x2, y2, and find the slope of the line connecting them. So the slope formula is the change in y, y2 minus y1, over the change in x, x2 minus x1, as long as we don't get a 0 in the denominator. Zeros in denominators are bad. The role of b, this number b, that was our fixed cost in a previous lecture. Numerically, when x equals 0, right, 0 times m is 0, our y value is b. This leads to the graphical role, which is the y-intercept of the graph, is the point 0, b. So this is frequently called slope-intercept form because m is the slope of the line, b is the y-intercept of the line, and so we can look at it and see, hey, here's my slope or tilt, and this is where it crosses the y-axis. In order to find intercepts, a little quick and dirty here. If I have a graph, x and y axes, the x-intercept is where a graph will cross the x-axis, and a y-intercept will be where a graph crosses the y-axis. Notice, for the x-axis, there's no height to it. We have not gone up, we have not gone down, so the y value is 0. The y-intercept here on the y-axis, we have not gone to the right, we have not gone to the left, the x value is 0. So I frequently say in finding intercepts, whatever intercept you're looking for, set the other variable to 0 and solve. Alright, we're going to have several examples like this. I love this example. We're going to decide which of the given functions is linear, and we're going to look at them one at a time, one slide at a time. But we'll take a look at it. Let's see. Use your knowledge of slope and y-intercept to write the equation. So here's a table of values for a particular function. We want to know, is it linear? And secondly, we want to know if it is linear, what's the equation? So the first thing I do is I start with the y-intercept. Well, when x is 0, my y-intercept is 7. So we can see the y-intercept is 0, 7. So if this is a linear equation, we know b equals 7. Now, the x values, they all increase by 1. To get to the next x value, we increase by 1. That's constant. It's consistent. So let's look if there's consistency in our y values. To get from 1 to 4, we subtract 3. To get from, no we don't, we add 3. Don't let me say that. 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 3, plus 3. It looks like we add 3 to get each new y value, and that's exactly what the slope tells us. As x increases by 1, the change in y is to add 3. So our function is 3x plus 7, our y-intercept. We don't have to find the slope, do this, do that. We can look at the patterns in order to find the slope and look at the table itself to find the y-intercept. So you don't have to use the slope formula every time. Our function g of x, once again, I start with the y-intercept. When x is 0, my y value is -2. So if it's linear, my b value is -2. My x values all increase by 1 each time. is there a consistent pattern with my y parts, my g? To get from 8 to 3, either adding or subtracting, I subtract 5. Minus 5, minus 5. Hey, look at that. I subtract 5 all the way along. So it looks like the pattern is to subtract 5. So I'm going to put that. A minus 5 is my slope. That's my pattern. Times x minus 2, because my y-intercept is minus 2. Let's try a value. Let's use 2. When x is 2, 2 times negative 5 is negative 10. Negative 10 minus 2 is negative 12. Hey, look, that one works. And you could try as many as you want and make sure your formula is correct. That's it. We're looking for patterns. Pattern recognition is huge when it comes to math. H of x. Oh, we don't have the y-intercept. That's a bummer. So let's look for our slope first. X increases by 2, right? For the values that we have, from negative 1 to 1 increases by 2. From 1 to 3, we increase by 2. So x increases by 2, what happens to our y values? To go from 6 to 10, I added 4. 10 to 14, I added 4. So as x increases by 2, my y values increased by 4. Remember, your slope is always change in y, plus 4, over change in x, plus 2. Plus 4 divided by plus 2 is a 2. So it looks like there is a nice, consistent, constant pattern of constant adding 4 to your y values for every 2 change in x. It does appear to be linear. So if everything changes by 2, for the next step, 6 plus 2 is 8, plus 2 is 10, plus 2 is 12, I could fill in these values. 6 plus 2 is 8. 10 plus 2 is 12, 14 plus 2 is 16, and going backwards, to go backwards I do the opposite. Instead of adding 2 to go to the right, I'll subtract 2 to go to the left. And using this, I can now see that my y-intercept is in fact 8. So h of x, the function with the name h, has a slope of 2, looking at the pattern of change in x and change in y, always change in y divided by change of x. 2x plus 8, our equation. This particular one is not linear. Now, why is that? Well, let's take a look. We see here, no problem. We have a y-intercept. Awesome. I might write that down. B equals 4. That's a question mark. That's an equal sign. My pen's not feeling me today. That's all right. Now, my x values. I'm adding 2 in x. All right? Each x, I add 2. So x, I add 2. What do I do for y? To get from 9 to 4, I subtract 5. 4 to 0, oh, I subtract 4. Oh, I subtract 3. Is the change in y constant? Is it consistent? Do I subtract the same amount each time? No. And because these y values do not change by a constant amount, we know this is not linear. So this particular function is not linear, and that's exactly how we would tell. Since x has a consistent change and y does not, we know there's no slope m, no constant change, no consistency. All right, find the slope if defined. Let's just look at some equations now. Y equals 2x over 3 plus 4. Frequently, you'll be required to rewrite some of these. And 2/3 times x might be a better way of looking at it. 2x over 3, that x could be in the numerator or it could be next to the fraction. It just can't be in the denominator. So 2/3 x plus 4, now we can see that the slope is the coefficient or number in front of x. Slope is 2/3. When x changes by 3, y will change by 2. More specifically, as x goes up by 3, because it's positive, y goes up by 2. Second example, 8x minus 2y equals 1. To find the slope, we're going to solve for y. So I'm going to subtract 8x from both sides. And I'll get a negative 2y equals a negative 8x plus 1. If you want to write 1 minus 8x, that's fine. But because I know we're working with linear functions, I'll frequently put the variable term in front. just so it looks like we're used to. At negative 2y equals a negative 8x plus 1, I'm going to divide every single thing by negative 2. Negative 2y divided by negative 2 is y. Negative 8x divided by negative 2 is 4x. 1 divided by negative 2 is a negative 1/2. And once we get it into a y equals mx plus b form, we can see that the slope, the m value, is the coefficient of x, which is 4. Let it be easy when you can. Math is as hard as you make it, so let it be easy whenever you can. Find the slope, if defined, of 2y plus 3 equals 0. I'm going to solve for y again. I'm going to subtract 3 from both sides, and then I'm going to divide by 2. I get y equals a negative 3/2. But I don't see an x. So what's the coefficient of x if there's no x written? Well, we could rewrite it as y equals 0x minus 3/2, because 0 times x is 0. And mathematicians, kind of lazy in our notation. We don't write zeros if we don't have to. But it's important to know that it's still there. 0 is one of the biggest things that we've come about in math last 2,000 years. I mean, there's other things that are really important, but 0 is big. 0x minus 3/2 is easier to see that my slope is 0. In general, if you have a y equals a constant, then you'll have a horizontal line, and a horizontal line has 0 tilt to it. No tilt at all. 0 tilt means the slope is 0. Find the slope if defined. 3x plus 5 equals 0. Last two examples, we've solved for y. How do we solve for y if there's no y? Well, we can't. If we can't solve for y, it's guaranteed we won't have a slope. We can solve this one for x. We can subtract 5 from both sides and divide by 3. X equals a negative 5/3. This is the equation of a vertical line. Every vertical line has undefined slope. Here's how I think of it. Now, I'm in the desert Southwest, and so skiing is not one of those things that we talk about very frequently. But if your positive slope, if you have a positive slope, you're going uphill, you're riding the ski lift or the tow rope if you're using one of those. If your slope is negative, you're going downhill, you're actually doing the skiing. If you have a horizontal slope, that's cross-country skiing. That's way too much work for me. And if you have an undefined slope, you're skiing down the face of a cliff and you're going to die. Don't do that, people. Don't ski down the face of a cliff. So undefined, because you will be undefined if you ski down the face of a cliff. Those are the 4 ways that I remember my slopes, the 4 different options. Positive is increasing. A negative slope will be a decreasing line. A slope of 0 is a nice horizontal line, cross-country skiing. It's a lot of work. Or a vertical line, x equals undefined slope, because you die if you ski off a cliff. Calculate the slope of the given pair of points if defined. Now remember, our slope formula is y2 minus y1 over x2 minus x1. Don't get in one of those situations where you outthink yourself. Just take them in order. Here's our first x and our first y. That's x1, y1. Here's our second x and our second y, x2, y2. So I'll subtract the y values. 2 minus 0 in the numerator. Negative 1 minus 0 in the denominator. 2 minus 0 is 2. And negative 1 minus 0 is negative 1. And when I divide, I get a slope of negative 2. For the points 4, 3, and 4, 1, I'm going to subtract the y values. 1 minus 3, 1 minus 3. 4 minus 4 in the denominator. 1 minus 3 is negative 2. 4 minus 4 is 0. When you have a 0 in the denominator, it's undefined. The way I remember this, it's one of the greatest things I've ever seen on Facebook, because there's not a lot of great things on Facebook. No offense there, Zuckerberg. I use it every day, but still. No. Right? That's how you remember it. If there's a 0 in the denominator, no, you can't have that. It's undefined. Calculate the slope through the given pair of points if defined. Negative 2, 4, and 3, 7. I'm going to subtract the y values. 7 minus 4. Subtract the x values in the same order, 3 minus a negative 2. Remember, subtracting a negative is addition, so 3 plus 2 is 5 in the denominator. 7 minus 4 is 3 in the numerator. There I go, 3/5, it's all good. Fourth example, if I have the points 4, 3, and 1, 3, I subtract the y values, 3 minus 3. Divided by, subtract the x values in the same order, 1 minus 4. 3 minus 3 is 0. 1 minus 4 is negative 3. And that's okay. Literally, that's how I remember it. Just like the no, it's okay if the zero's in the numerator. I have 0 M&Ms, and 3 angry people want to share them. Well, everybody gets 0. That's just the way it is. But in the previous slide, if I had 4 M&Ms and there was nobody there to eat them, it's just a weird situation. It's undefined because there's always somebody to eat M&Ms. Okay, let's find a linear equation whose graph is the straight line with the given properties. I like to keep it with our y equals mx plus b. So if I'm going through the point 2, 1 with a slope of 2, we know that m equals 2. That's the first thing we're given, so we're going to use that. But we're also given an x value and a y value. And we have our equation. So let's use all those facts together. Let's substitute for y. Y is 1. Equals m. Our slope is 2, so I put in a 2. X is 2, so I put in a 2. Plus b. I have no idea what b is. Let's solve for it. 2 times 2 is 4. If 1 equals 4 plus b, I can subtract 4 from both sides. 1 minus 4 is negative 3 is equal to b. I have my slope. I have my b. I can write my equation. Y equals a 2x minus 3. Let it be easy. Let it be straightforward when you can. You're given an x, you're given a y, you're given an m. Y, m, x, you can find your b value. Again, through the point 0, negative 1/3, slope is 1/4. So we're given m equals 1/4. But you see, I'm going to be lazy when I can. Look at the point we're given. We're given an x value of 0, guaranteed to always be a y-intercept. Which tells us, hey, your b value is a negative 1/3. If you know the y-intercept and you know the slope, you know the equation. Y equals 1/4 x minus 1/3. Work smart, not hard. Think about what you have. If you're already given a y-intercept, you can just plug the answer in. If we're given 2 points through the point 2, negative 4, and the point 1, 1, we're not given a slope m, so we have to find it. Well, we just did this for several examples, so we can find the slope. 1 minus a negative 4 divided by 1 minus 2, always y over x. 1 minus a negative 4, that's 1 plus 4, which is 5. 1 minus 2 is a negative 1. 5 over negative 1 is negative 5. I have a slope. Now, with the slope, I could choose either point to use. I could do both of them if I wanted to, but I'm going to take the easy one, and I choose 1, 1 to be, quote, the easy point, because it doesn't have a negative. I'm going to use small numbers, and I'm going to use positive numbers as much as possible. So my y value is 1. My m value is negative 5, because I just found that. My x value is 1. I can find b. If 1 equals a negative 5 plus b, I'm going to add 5 to both sides. 1 plus 5 is 6 is equal to b. Now that I have m and b, I can write the equation of my line. Y equals a negative 5x plus 6. And our last example of this section. Find a linear equation whose graph is the straight line, that's how we know it's a linear equation, with the given properties. It goes through the point 1, negative 4, and 2, 5. Same thing. We always have to have our slope. So we'll subtract the y values. 5 minus a negative 4, divided by 2 minus 1. 5 minus a negative 4, that's 5 plus 4, which is 9. 2 minus 1 is 1. 9 divided by 1 is 9. Found our slope, awesome. Now we can choose either point, and if we choose either point, I'm going to choose the one that has all the positive values. That way I don't have to worry about subtracting negatives and getting all confused. So my y value is 5. My m value is 9. I just found it. My x value is 2. plus b. 9 times 2 is 18. If 5 equals 18 plus b, I can subtract 18 from both sides. A 5 minus 18 is a negative 13, which equals b. We have our m. We have our b. We can write the equation of the line. Here's just a little sideline for you. I'm going to shrink this down a little bit. Of course, my highlight's not going to work out for me anymore, but check it out. What if I used the other point instead? Negative 4 equals 9 times 1 plus b. It'd be nice to know that I'm going to get the same answer no matter which point I use. It's easier to trust me that way that you could use the, quote, easy one. Well, check it out. Negative 4 equals 9 plus b. Subtract 9 from both sides. Negative 13, that's a 13. It's an ugly 13, but it's a 13 nonetheless. Negative 13 equals b. That's what we had using the easy point. That's what we had using the other point. It's still an easy point, but is not as easy as 2, 5. So it doesn't matter. Use whichever one is easiest for you. Don't worry about making a, quote, wrong choice here. You can't make a wrong choice. If you use the 2 points to find the slope, use either one of the points to find your b. It's going to be the same either way. There's only one linear equation that goes through these 2 points. You're doing terrific. Thanks for listening.